Welcome to the Getting Started video. Today, we will show you how to get started with the Intel Programmable Acceleration Card with Intel A10 GX FPGA, abbreviated as Intel PAC. The Intel PAC is a PCIe-based card and is supported by the Intel Acceleration Stack for Intel Xeon CPU with FPGA that provides optimized and simplified hardware interfaces and software libraries, thus abstracting away the hardware-specific FPGA resource details and establishing a common developer interface for using FPGA acceleration. We will visit the Intel FPGA Acceleration Hub webpage, which hosts the documentation, downloads, and other resources, walk through the installation process, and then verify our install. Now let's explore the Intel FPGA Acceleration Hub webpage and navigate the tabs. Refer to the Platform tab to read the product specifications of available acceleration cards and pick the one that fits your needs. The platform we focused on in this video is the Intel PAC with A10 GX FPGA. Please refer to the list of OEM partners and qualified server models with associated best-known configurations and pick your desired server with the Intel PAC. The Software tab provides the acceleration stack downloads to get started with both running and developing acceleration workloads. There are two flavors of the acceleration stack provided. The Runtime Environment, or RTE, has a smaller footprint and can be used by software developers to develop and integrate their host applications with available accelerator function workloads. The Development Environment, or Dev, has the capability of the runtime package and additionally includes the tools required to build accelerator function workloads. For older releases of the stack, please refer to the archived versions link. Please find all of the collateral, training, and resources for the Intel PAC on the Resources tab. The datasheet, release notes, and Intel Acceleration Stack Quick Start Guide will be the first set of documents to refer to. Intel has engaged with leading providers of accelerator workloads best suited for FPGA acceleration. These solutions include, but are not limited to, data analytics, media processing, and financial and genomics libraries. You can refer to the items on this tab to see the vertical market segment breakdown of the available partners and the solution they have developed. The following are the system requirements you must take into consideration before installing the Intel PAC with A10 GX into a server. You will need a motherboard with a 16-lane PCI Express 3.0 compliant slot. The card has space, thermal, and power requirements that are outlined in the datasheet. Internet access is required when installing the software stack. Based on the selection of runtime versus development software packages, the system requirements for memory and storage will vary. Refer to the Quick Start Guide for this information. Each pack will have a list of supported operating systems and servers. The Intel PAC with A10 GX supports CentOS 7.4, Red Hat 7.4, and Ubuntu 16.04. For the list of qualified servers, please visit the Platforms tab on the Acceleration Hub and refer to the line items with your specific accelerator card. When you order a server from one of our OEM partners, it comes with an integrated PAC. The following are the instructions you must follow if you need to swap the PAC. The following are the installation steps you must follow when installing the Intel PAC with A10 GX in a server. First, power off the host machine. For an enclosed machine, remove the casing around the motherboard. At this point, you may optionally attach the micro USB cable to the micro USB port on the PAC and the USB 2.0 interface on the server. This cable is only used for debug and as a second option for firmware updates. After gaining access to the motherboard, plug the Intel PAC with A10 GX FPGA into an open 16-lane PCIe slot. Reinstall the casing on the server. At this point, installation is complete and you may power on the server. The Intel Acceleration Stack for Intel PAC comes in two flavors, the development and the runtime package. The development package includes everything present in the runtime. The installation process does require both sudo access and internet availability. Users who plan on developing workload solutions will want to download the development package. Other users who plan on only using board management and workload deployment need only download the runtime package. To begin the installation process, visit the Acceleration Hub and then download the software package that fits your needs. Next, you will need to untar this archive. Use the command tar-xf to do so. After the archive is unpacked, run the setup.sh script. This script installs the Intel FPGA PCIe drivers and the Open Programmable Acceleration Engine, also abbreviated as OPA. This framework consists of libraries and utilities to facilitate development of software applications and accelerators. A description of the OPA SDK can be found at the OPA GitHub website. Now that installation is complete, we can run the lsmod command to verify that the FPGA drivers have been installed. Pipe the output of lsmod into grep and search for the expression FPGA. We can also verify that the OPA library has been installed by running rpm-qa, piping that into grep, and searching for the expression OPAE. At this point, both the card is plugged in and the software release has been installed. We can now verify that the card is seen by the operating system. Open a Linux terminal window and enter the lspci command, pipe the output into grep, and search for the device ID of your chosen accelerator card. In the case of the Intel PAC with A10 GX FPGA, this is 09C4. If the card and associated software have been installed correctly and found by the OS, you'll see the card with its device ID listed. As a part of the OPA SDK, various utilities have also been installed. You can find the full list and their functionality on the OPA GitHub webpage. Let's review some of the important ones. The FPGA Flash utility will update the static FPGA image loaded from Flash at PowerOn. The FPGA Info utility displays the information about the FPGA platform. The FPGA Conf utility configures the FPGA with an accelerator function. The FPGA BIST utility performs self-diagnostic tests on the FPGA platform. This command validates the card installation by running two specific tests. These include PCI link status and data bandwidth tests. To run the native loopback test, load the NLB Mode 3 green bit stream onto the FPGA with the command sudo FPGA BIST OPA platform root hardware samples NLB Mode 3 bin NLB Mode 3.gbs. To run the DMA test, load the DMA AFU.gbs green bit stream onto the FPGA with the command sudo FPGA BIST OPA platform root hardware samples DMA AFU bin DMA AFU.gbs. Finally, we will walk through running a simple Hello FPGA example. This requires us to first load the accelerator function using the FPGA Conf utility. After loading the AFU, we will need to run the host application. This host code searches for a predefined and known AFU called native loopback adapter on the FPGA. If found, it acquires ownership and then interacts with the AFU by sending a 2 MB message and waiting for the message to be echoed back. This code exercises all major components of the API provided by the OPA: AFU search, enumeration, access, MMIO, and memory management. For more information on the OPA and its API, refer to the Resources section on the Acceleration Hub under the OPA C API Programming Guide. The acceleration stack for Intel Xeon CPU with FPGAs is a robust collection of software, firmware, and tools intended to make it easier to develop and deploy Intel FPGAs for workload optimization in the data center. Check out the acceleration trainings available on the Intel FPGA training site. Embedded are hyperlinks which will take you to the course registration. If you are a software developer, then check out the list of trainings catered to you, starting with the Introduction to Intel FPGAs for software developers. If you would like to learn more about the OpenCL flow and high-level design, please visit the Intel FPGA OpenCL training webpages. You are encouraged to check our complete training overview and catalog for all other topics. Lastly, please consult the various Quick Start guides and developer guides associated with the acceleration stack for more information.